Okay, so yesterday we were at this. Before we went on to solve any problems, the task was to practice recognizing land graph height and making color highlights on land graph height. For every question, even to these questions, we also did the highlighting before we look at the question. Now, coming to this, when we did the highlights earlier, we didn't look at the question at all. Okay? Then we wrote here. Then I realized there's something that's tricky about this. And Rion asked me about this question this morning. And he said his tuition teacher says so and so and whatever. And then I'm like, what do you think then? I think that's the important part. Now let's look at this question. And even I myself got a bit confused, especially after what Rion said. Now, then we take a closer look. There are some highlights, and this was yesterday. We stopped here yesterday. Okay, I'm going to take out my pen and pencil to highlight it more. Okay, for this question, let's look at it closely. It says here, a rectangular a rectangular container is partially filled with 1 cm cube stone. Partially filled means it's not completely filled, there are some cubes inside. And the thing is about cubes, they are not liquids. Usually when you pour liquid, because of gravity, it will just fall to the bottom, right? But these are cubes. So cubes are solids that can be stacked up. So you notice that there's some space that's empty. Now then the key part of this question is asking you, for the volume of the container that is not filled with cubes. That means there's space there. You understand what I'm saying? The space there. Now, then there are some measurements we identified. Yesterday we said the height is 3. Any confusion about the height being 3? No, that's quite clear, right? You can see if I zoom in. Either side is 3 cubes here and then 3 cubes here. Quite clear about it. But then the length and the breadth starts to get a bit confusing. We said the length was 9. Why is the length 9? Because we look at the cubes that are lining up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 cubes that are lining up here. So if I were to take like this over here and the cubes. This morning I took the cubes and I was lining up with him and asking him to see. These are the cubes I've got from the P1s. They are interlocking cubes, so slightly different. Okay. Now, the thing about these cubes is that when it reaches a corner, it's like sharing a side. Can you see? Like previously we talked about hidden cubes, right? Right? Previously we talked about hidden cubes. If I look at a certain direction, some cube is going to be hidden. Can you tell? So from the top view, I can see this cube, I can see this cube, and I also can see this cube here. But once I turn it this way from another view, can you see the cube that's hiding behind? Not quite, right? You know what I'm saying? So when I count the length from this side, I can see this one here, and this one. So that's 3. Okay? So if I look at this one again, I can tell 1, 2, 3, 4, 5, 6, 7, 8, 9. The length is 9 cm. But I say the length is 9. The length of what? Is it the length of the container or the length of the space that is not filled with cubes? So 9. 9, is it the length of the container or the length that is of the space that's without cubes? Let's take a vote. Okay? If you think that the length 9 is 9, length of the container, you put a thumbs up. If you think that Let's see what reactions we have. Okay, we can put a various reaction. If we think that the length 9 refers to the container, you put a thumbs up. Okay. If you think that 9 refers to the space that is not with cubes, you put a raise hand. Okay. If you are, I don't know, then you put what face is this? Our face. Yeah. Oh yes, no you don't have this fancy reaction. Okay, how about this? If you feel that is the length of 9 is the container, you put tick yes. If you feel that 9 is the length of the space, then you put cross. Okay, I see. If you feel that 9 is the length of the space, you put cross. If the length 9 is the space of the container, you put tick. Is it okay? Okay, I can see. Lots of ticks here. Okay. And I have a cross here. Okay. Question. Find the rules of equation. Now it's out. Again, never mind then. Okay. Okay, back to my speaker view. All right, so some this and some, most of you are saying that 9 is the length of the tank. Okay. Then the next question is, then what is the length of the space then? What is the length of the space that is not filled with cubes? So I look at the graph 5. I wrote 5 there. How are you counting when I wrote 5? How do you see I got 5? Can you see where I got the 5 from? Is it from the inside or from the outside? You see, I wrote 5 here. Is this graph 5 from the inside of the container or the outside of the container? You realize if I counted from the other side, like this is, let's say this is the, okay, this is the other side. Okay, can you see if I count from inside how many for the breath? I say it's supposed to be, how many cubes on top here? Can you see? 1, 2, 3, 4, 5, 6. Actually 6 on one side. Okay. So if I were to join 6, okay. So it looks something like this from this corner of the tank. Can you see this? Can you see, right? Now, from the top, it says 1, 2, 3, 4, 5, 6. 6 cubes, right? Does it look like 6? So if I look at the outside here, what's the breadth? Can you see? From the outside here. What is the breadth? 1, 2, 3, 4, 5, 6. Can you see 6? Then where's 5? How come it's 5? How come there is a word 5 there? Can you see the inside? Imagine I turn this and I look inside. What's on the inside? 1, 2, 3, 4, 5. Can you see one side is missing? Can you see? So actually, for this side here, I could write down a few things. For the rectangular container, the container itself, no matter with the cube or without the cube, the length was 9 cm, the breadth was 6 cm, and the height was 3 cm. However, things change when I fill the container with some cubes. What changed? The breadth inside here changed. The length inside here changed. Can you see? So, if I talk about the volume of the container that is not filled with cubes, I'm talking about the space which I am coloring here in green. Can you see? And for this space here, this is the container. The container, the tank itself, with or without cubes. But when I refer to the container space not filled with cubes, is different. The length is inside. Inside, what is it? It's actually 1, 2, 3, 4, 5, 6, 7, 8. Actually 8 cm. Because 1 cm is occupied by the cube. And then the breadth, it became 5 cm. Why is it 5 cm? Because 1 cm occupied by the cube. Can you understand? And then finally, the height, is it still 3 cm? It's still 3 cm, right? Nothing is changed. Now, so this is the important part. Yesterday, when we were highlighting, we recognized length, breadth, height, length, breadth, height. But there's a big problem here. What breadth are we talking about? Breadth of what? Length of what? Height of what? So all these measurements yesterday were estimations. They were not true. You understand? What is true is now we look here. After I read the question, that's why I say you still must read the question. Eventually, the question says a different thing. The question shows you a container. The container 9 by 6 by 3. But I count in cubes that stack up along the sides of the container. Can you understand? So, the volume of the container, when it's not filled with cubes, there is this part now that we are talking about. It's actually length times breadth times height is actually 8 centimeter times 5 centimeter times 3 centimeter. And that's 40 times 3, that's 120 cubic centimeters. Can you understand? Okay, move on to the next question. That's here. Now, in this case, we are talking about stacking the cuboids after I chop it up in threes. So a quick read of the question. The cuboid measuring 27 centimeter by 50 centimeter by 10 centimeter. We are looking again at the length, breadth, and height. Cut into 3 rectangular blocks, after that stack them up. Now there's a long method. The long method is the whole thing, figure 1. I calculate the area, then I divide by 3, then I times 2, you know, long story. But actually don't need. Why I don't need the long story? I try to understand the question better. I take this rectangular block, I cut into 3. Now, what is the length of each rectangular block? This figure 1 is a cuboid, yeah? I'm talking about rectangular block. So for the cuboid, in figure 1, the length is 27 centimeter, breadth is 15 centimeter, height is 10 centimeter. Okay, I chop it into 3 rectangular blocks. I'm talking about the rectangular blocks now. Rectangular blocks that is cut into 3. There are 3 of them. I'm talking about one each of the rectangular block. Each one. Each one, what is the length? How do you get 9? Very good. How do you get 9? Very good. So I chop it up into 3. So I'm looking at one block. Okay. So meaning each one, the length is 27 divided by 3. That's 9 centimeters. The breadth, is it the same? Is it 15 still? Yes, it's still 15 centimeters. Oh, but the height is still 10 centimeters. Very good. I hear you. Very good. I should have unmuted you and then you share your ideas. Huh? Okay, that's really very good. Now, then we are, all this, is it the answer yet? No, because we move on to the next part of the story. You are stacking up the blocks to form another cuboid. This other cuboid is figure 2 cuboid. This other cuboid, figure 2 cuboid, has the cubes, has the blocks stacked up like that. Okay, and the question ultimately is asking us to find the volume of figure 2 cuboid. So, figure 2, what's the length? 9, very good. Because this is 9, right? 9 centimeters. The breadth is 15 still? Okay, very good. How about height? 20. How do you know it's 20? 10 plus 10. Very good. Can you find the volume already? Yeah. So volume, that's the answer. Volume of cuboid 2's figure 2 cuboid. Yeah. Length, breadth, height. Length times breadth times height equals to 9 centimeter times 15 centimeter times 20 centimeter. Is it okay? So I have 180 times 15. Okay? And then you solve it yourself. Okay? Right. This okay, right? Okay, then move on. Now move on to the new item now. We are looking at 10. So eventually, eventually I can recognize length, breadth, height is not good enough. I need to be able to tell which length, breadth, height am I supposed to use. Is it clear? Okay, next. Now, these questions are important to help us to solve the next few questions. These few questions that involves now liquids. I can pour liquid into containers, which is this set here. Okay, now, if you look at your textbook, I share the screen now. On this page here, page 131, it talks about having liquids and 10 by 10 by 10 cm container. So yesterday I brought this out. Okay. My 10 by 10 by 10 container is actually this one here. If you see at the side of my screen that I spotlight, can you see? And let's fill in this portion first in our textbook. Okay. Let me pick up my textbook. That is page 131. Are you going to see? Okay, so over here, this is the container. Okay, I'm not pouring liquid in. I'm pouring planks in, pieces like this in. Okay, and it is 10 centimeter by 10 centimeter by 10 centimeter. Okay, what happens is actually the volume of the water in the container, based on the container of 10 centimeter by 10 centimeter by 10 centimeter, is actually 10 times 10 times 10. That gives you 1,000 cubic centimeters. But the idea is that we are looking at this as liquid. So ultimately, this is a relationship we need to establish and remember well. And we're able to do our conversions of measurements. So this one is very important. 1 liter is 1,000 milliliters. So relationship between milliliters and cubic centimeters is 1:1. We'll talk about this in the next chapter, ratio as well. So 1,000 milliliters is 1,000 cubic centimeters, and 1 centimeter is 1 milliliters. So 1 liters is 1,000 cubic centimeters. Okay, there's this part talking about the water level. Okay, I'm not going to pour the water in the container, but I'm going to use this to help. Okay. Okay, so if I were to slot all my orange pieces inside, this is the the container when it's full. Okay, all right, the container when it's full. But let's say if I empty it, okay, the container's capacity is I'm going to allow you to unmute yourself so we can hear each other. Okay, but of course, please only one at a time and speak. We allow to unmute. Unmute. Okay. Okay. Now we can hear each other. Now the question again is this. This container here is empty. I told you already the containers length is 10, height is 10, and width is 10 centimeters. So 10 centimeters and 10 centimeters. The volume of the container is nearly 1 cubic centimeter. Okay, so I'm going to this container is capacity. It is written here 1,000. I need to zero. Right. I think it's better to stay mute.
Yeah, mute it. Mute. Mute it.
Bye bye.
If I either type in the chat or you can voice it out loudly, I'll repeat for you. Okay, so Hannah says you saw the container when it's full, it will be 1,000 milliliters, meaning 1 liter, meaning 1,000 cubic centimeters, right? Okay, imagine I start to fill the container with some liquid. In this case, I use this block to demonstrate. Okay. Okay, it's 100 milliliters now. I write here 100 milliliter. Okay. And the capacity, you'll be using the same one. All of it will be, okay, just A and B and C. That means 1 liter, 1 liter, 1 liter. I'm just using the same container. Okay? Now, looking at this now, how much water is inside? 100 milliliter. If you talk about it in cubic centimeter, how many cubic centimeter? Can we talk about this in cubic centimeters? I mean, after all, this is a cuboid, right? Now, let's talk about this one cuboid here. What is the length? 10 centimeter, right? What is the breadth? 10 centimeter. Okay. So that's why it's 10 times 10, right? So I told you the height is like here, right? So it's 1 centimeter height. 10 cm times 10 cm times 10 cm. So it's 100 cm cubic centimeter. Okay, I see some answers. Some say 100 cm cube. 10 times 10. Some wrote 10 times 10. Some people wrote 100 milliliters. Okay, that's correct. Yes, written here. But in cubic centimeter units, can you see? 100 cubic centimeter. 10 times 10 times 1. Okay, let me take another one more piece, put inside. And then I take another piece, I put inside. And then I take one more piece, I put inside. Altogether, I put inside 4 pieces. Okay? 4 pieces. What is the volume? 400. Very good. 400 milliliters. Okay. What do you think it is in cubic centimeter? So 100 milliliters is 100 cubic centimeter. So 400 milliliter is very good. I see you typing in the chat group. That's great. So 400 centimeter with a little tiny tree. So 400 cubic centimeter. Are you able to see on my screen? Now I just write 3 at the back. So I will be able to tell your tree is a tiny tree. Supposed to be a tiny tree. Not supposed to be a big tree. But when you write on your book, you write smaller. Okay, then let's talk about the formula. Length times breadth times height. So the length and breadth change. No, so it's still 10 centimeter times 10 centimeter, right? How about height? Very good. 4 cm. That's the height. Okay? Okay. Is it difficult to understand? Okay. Let me ask you, what's the volume of the empty space? The tank not filled yet. So if I want to add, I want to fill until it's full, how much water should I add some more? 600 milliliter. Very good. So 600 milliliter, if I convert to cubic centimeters, what will it be? 600 cm with a little tree, right? So 600 cubic centimeter. What will be the height of the water? 6 cm. Very good. Can you understand? Okay. What about, let's introduce fraction. Make it a bit more challenging. Fraction. Now I want this container to be half full. What will be the height of the container? 5 what? 5 cm. Very good. Can you understand? Did your breadth change? No. Length change? No. What changes? Height. So if I half full is 5 cm. Okay, what's the volume? 500 cm cubic centimeter. Okay, good. Very good, very good. Okay, let's try fractions again. If it's one whole tank, right? is 1000 cubic centimeter, right? And then the length is 10 centimeter, breadth is 10 centimeter, height is 10 centimeter. If I have 4/5 tank full, if the tank is 4/5 full, 4/5, fraction 4/5. Okay, I want it to be 4/5 of filled. What is 4/5 filled? Yeah, 4/5. What is 4/5? 800. How do you get 800? 4/5 of. What do you think will be the height? Since we agree that the length and breadth never change, is the height change. If it's 4/5 filled, what will be the height? If it's full, what's the? If it's 8 centimeter. Thank you, centimeter. If it's full, what's the height? 10 centimeter lah, correct. If it's full, it's 10 centimeter. Okay. If it's 4/5, 4/5, if I convert to equivalent, 4/5, right? If I convert the equivalent 8 of 10, right? So the height will become 8 centimeter. So the volume is 800 cubic centimeter. So 4/5 will be 800 cubic centimeter. Can you understand? And actually, I do not have to do 4/5 times 1000. All I need to do is 8 centimeter. Can you understand? Cannot. Okay, now challenge. Samantha, build our income now. Akil, come help us. Both Akil's okay. Akil. Okay, now challenge for those of you who are waiting. Let's straight over to the next page here. This over here, let's try this one first. On page 132. Give you 5 minutes to do the conversion. Are you ready? Okay. Oh. 5 minutes to complete the workbook. Textbook, sorry, page 132, question 1 and 2. Let's do some conversion first before applying our next level knowledge. Okay? Ready? 5 minutes, question 1 and 2. In the textbook first, After we practice this one, we'll do the one in our workbook. Are you okay? Is this okay? Okay, I share the timer. What's my timer? Okay, 5 minutes, ready to go. 5 minutes. Ready? Yeah. So question 1 and 2 in our textbook, page 132. We practice first, then we try with our worksheet. And try. Oh, let me see your open the gun. Get up here. practice with the textbook first, then after that do velocity. Okay, textbook. Yes. Okay. Then okay, then after that I will ask you to show your answers to the screen. How many you can't finish if you have to do it at the same time. What is he doing? Not to know where I'm going to do. 3, 4. What are you doing? Anybody has decimals and answers? No. I'll give you a clue. Some questions requires decimals. Maybe. Especially the one in the book. Please. Okay. Okay, one more minute. Okay. Listen, okay, get ready to splash your answer on the screen. Okay, ready? Okay, let's see. Choose you. How do you know why let's go? Okay, let's take a look at the gallery now. Gallery. All right. Ready? Choose me. Yeah, choose me. Okay, Yarrow, where's your answer? Huh? I want to just see you eating, okay? You're not doing a live stream of how this is food. Okay? The what? Tomorrow show? Show promotion. Atisha, where's your answer? Okay. Good. Okay. Right. Stay home. Still okay. Empty table. What's the answer? Match it. Okay. Okay. Hannah says, X spotlight. Okay. Hannah, let's take a look at your answer. My answers are on the left. Okay. And yours on the right. 9 milliliter is 9 centimeter cube. Okay, 9 centimeter, 6 meters is 6,000 meter. You write your units? Good, you wrote units. Oh, mistake over there. I recognize. 159 cubic meters, 8,034 cubic meters. Look at question number 2. Anybody can tell me what is the mistake in front as well? Yes, Ayla. Anna. Please show your friends so that you can find out the mistake and learn mistakes together. Anna, don't move, please. Okay. Anna, you put the wrong units. It should be liters for decimal or 69 milliliters. How do you get the decimal? Tiffany asked just now, how do you get the decimal? Okay, thank you, Hannah. I'm going to remove you from the spotlight. Can you see? This is mine. Do you have the same answer as mine? Can you see the units? Can you see how I got my intermediate steps? Is this okay? Can or cannot? Can or not? Can. Now, here says liters and milliliters. So it's okay, you do not really need the decimals yet. But term 3, when we learn decimals for P5, we need to know how to do this. Again, to answer Stephanie's question, what I did was I used 69 divided by 1000. And that's how I got 0.0. Okay, liters. Can you understand? Okay, now with that, who's gonna? Oh, correct. Please put please show me. You cannot put. You can only put raise hand. Correct or wrong? Correct or wrong? Is it? Yes. Okay. So if you got all correct, can you put raise hand, please? Okay. Yeah. Okay. Very good. Okay. You. I can see you. Okay. Now you've got your worksheet. Yes. Anybody is got the worksheet? Can I have a question? Sorry, you don't have the worksheet. Yeah. Then why you raise your hand? I say raise your hand if you don't have the worksheet. Okay. I have one nameless here. Anybody missing our worksheet? No, yes, no. Okay, I've written here homework 19/4, today's homework. Please try this out at home. Yes, just this page. Is this manageable? So here as indicated, okay, is indicated here. Express in the following measurements in cubic centimeters, liters or milliliters, or the word is or, and then the last one, liters and milliliters. So for this one here, I'll help you out. If you're struggling with this, okay, for this one, I'll just help you with this one, okay? Are you listening? Yes. Can I continue? I'll just help you with this too. So for this one, I'm going to write here on the top here, okay? 1 liter equals 1000 milliliters, and that's 1000 cubic centimeters. And 1 milliliter is 1 cubic centimeter. Is this okay? Okay, I write down here to help you. Now, so if I have to do the conversion, bigger unit to smaller units, I multiply by the thousands. From smaller unit to bigger unit, I need to divide by the thousands. Is this okay? So in this case, come, let's ask. Atisha, 8 liters and 7 milliliters. What should be the answer? 8 liters is 8,000 milliliters. Then I plus 7 milliliters. You should get 8,007 milliliters. So the answer should be 8007. Okay. Now, what about this one here? I have 450 cubic centimeter, but I know that to get 1 liter, it must be 1,000. So looking at this is smaller than 1,000, right? So I must divide by 1,000. Because it's not a whole, it's not a whole. So I can look, I count backwards. From the ones place to the tens place to the 100 place, I still need to go back one more place. So my answer will be in decimals. So if there's a decimal point here, I'm going to shift 1 place, 2 place, 3 place, it will be 0.45 meters. Can you understand? So right now I've introduced to you this shortcut. You'll be practicing this shortcut when you are in the next chapter of decimals. Can you understand? So far, okay? This one should be okay. Small unit to small unit. So it's still just 25. Right? And then the last one here is a combination of units. So I will have 1 liter and 3 milliliter. Is it okay? So this homework. Do by yourself, okay? Okay. For the last bit of today's lesson, I just want to try to go through one question here. That's page 152, question 5. Okay, just one question. Let's try, okay? Is it okay? Now, on page 152, question 5, and page 152, question 4, you need to really look at some of the important words. We really have to read the question carefully. Now we are looking at problems that involve things like partially filled. And then the units become a bit more complicated. In some questions, it asks you to express the volume in liters and milliliters. So this one, question 4 requires a combination of volume in liters and milliliters. And then for this one, here, Audi, where's the worksheet? Is it with you? Audi, is the worksheet with you? Okay. So you have this one here, one keyword partially filled. Another keyword, you need the units in liters and milliliters. And for this one here, this question, it gives you just like the cuboid. Now, I would like you to think about it. When you look at this, can you imagine this tank here is made up of 2 cuboids. The filled component and the empty portion. Can you understand? The filled and the not filled. One is a blank, empty. It's like 2 cuboids stacked together. Can you understand? So likewise in this situation here, in this rectangular tank, okay, it measures, tells you already, 27 meters by 12, 35 meters by 22 meters. Can you see? So if I highlight, I have the length, same as before. Breadth, same as before. Height, same as before. Are you able to get this? No, but that's not all. Right now, we are no longer asking about the container itself, the tank itself. Because there's this keyword of partially filled with water. And you're supposed to find the volume of water in the tank. Now, I'm going to go with the easiest method. There are more than one method to solve this. If you look at your textbook, there are like multiple methods. Okay, I'm going to go straight forward into the easiest method, which I think you'll be able to tell me. Now, if I want to find the volume of the water in the tank, do I have the length of the tank? Of the water? Yes, right? I have the length of the volume of the water. If I want to go straight to just the water, not the tank. Water, the water. I can use still length times base times height. Now, my question is the length still 27? Yes, very good. It is still 27 meters. What about the breadth? Yeah, it's still 25 meters. It's still the same. What about the height? What should it be? 8 meters. I see meters and 8 meters. How do you get 8 meters? Very good. So tank is 22, but I must minus the empty one. I don't need the empty space. Okay. Then I just get the height of the water. This is 8. Can you understand? And then I calculate this, I will get an answer cubic meter. Now, the questions here didn't require us to convert this into liters and milliliters. So no conversion is necessary. Can you understand? So I do my raise, and my final step, the reminder is, I just cubic meters. I don't need any conversion. Can you understand? Now, if you look at if you look at the textbook, right, it shows you many methods. Like for example, this one here. After you find the volume of the tank, then you minus the volume and do volume of the empty tank, then you minus together. Now, do you think it's easier just to deal with the height? It is, right? So I don't have to the whole tank minus the empty volume, then get the volume. I can just go straight forward using the height. Can you understand? Okay, is this okay? Now, so your homework is just this page, right? Okay. Tomorrow we will aim to complete volume, the chapter of volume. All right, this chapter with the work problems. We will not be doing all the work problems, just selected ones. Okay. So far, so good, everybody. Okay. Say goodbye and thank you, everybody.